Hello, welcome to my first problem think aloud video. Um, so what I'm going to try to do is when you guys suggest problems that would be helpful to you to hear how somebody thinks about them, that I'll make a short video of working on it. As we go along, if you can think of anything to make these videos more helpful, please suggest it, either email, comments on the discussion board, um, whatever way you're comfortable communicating. So this first video has two problems sent along by Samantha. As I said, I'm going to try to make these kind of think aloud. So to go through my process like if I was taking a test. So instead of being a teacher kind of recommending to you how to do them, I'm going to try to share how I would think about it if I saw it on test. So the first thing is to read it carefully. Right? So most students can expect to see their grade point averages increase by 8.2% after taking Mrs. Wilson's review class. George's average prior to the class is 72. What can he expect it to be after taking the class? Okay, so I think about what is the question asking for? What it here is going to be his average after taking the class. So we're looking for a number. Um, the review class makes it go up, so we're going to expect a number higher than 72. So I might have thought that maybe some of these I could eliminate based on that it's going to be going higher, but not the case. They're all high. Now, I like to estimate to have some sense of whether I'm doing calculations correctly. So 8.2%, that's around 10%. That would be up 10% of 70 is 7 points, so 79. Well, that makes me think that this is going to be the only reasonable answer. Okay, so the next thing, I'm going to shift gears just a little bit. As you're doing these practice problems, focus on the ideas, right? So the idea here is percent, right? So these percent problems, whenever you're thinking kind of percents, you should be thinking, okay, those are like fractions, which are like decimals. So that's kind of your point of view. And anytime you see kind of a fraction, a decimal, a percent, one of the main questions you should think of is kind of percent of what? Fraction of what? Right? So increase of 8.2% of, well, of their score before, right? What are they increasing? They're increasing their score before. So we're looking for 8.2% of the 72. So that's going to be 0.082 times 72. So I put that into a calculator. Actually, I use Google for my calculator most often now, and I got 5.9. So that's the increase. Now, if I was writing this problem, I might have put a 5.9 here for a distractor, right, to make you think, oh, when you got this number, that's here. But this problem doesn't have that as a distractor. That's the increase. So then the score we're looking for is this 72 plus 5.9. Right? And I might have also put a none of the above to get people who are thinking kind of too literally. But that means I think that the answer is this 78 that I was expecting it to be. Now there's a shortcut sometimes with these percentage problems. What we're really doing, now this is me shifting into teacher mode, right, is we're adding 72 plus the 72 times the 82 thousandths. So one thing a mathematician might do is factor this out, right? So we can really do the whole thing in only one step. And a lot of times you'll see this in kind of sales problems or tax problems. 72 times 1 and 82 thousandths, then that's going to be the 77.9 in one go. So about 78. Okay, now time to switch to that second question. Okay, so Samantha's second question is a geometry question, and she didn't include the circles, she just sent this in an email. We've got two circles and one's a bit bigger than the other one. And then it's questions about congruent and similar. So really this is asking us to sort out these two ideas. So congruent is a geometry word for the same. So we might say two numbers or two equations are equal, but in geometry we would say they're congruent. So these two circles, they are not exactly the same. That's what congruent means. Like we could move one to exactly cover the other one. They're different sizes, so they are not congruent. So they're not congruent, so that eliminates this one. And then D also says they're both congruent and something else. And they throw in, this I think is a distractor, right? Equal, that's not even kind of on our radar because we're trying to think in geometric terms. Okay, so the question remains though, are they similar? So when you hear similar, that might make you think of similar triangles. So what mathematicians think when we think of similar is we want to think about things that are proportional. So that if this part is half times longer, then this part will be half times longer, the part that it compares to. So we might think when things are similar, they look like an enlargement or like they've been shrunk. Right? So that fits these two circles, right? One is like an enlargement of the other one. If we had them in a Photoshop program, we could blow up the one circle and make it exactly the same size as the other one. So they are similar in this mathematical sense. So they're similar, yes. They're not congruent. They are not congruent, nor similar. So that's a close reading one, right? So the similar works it out. So this is the only possible answer, this part B. Okay, so congruent, we're thinking things that we could move one to cover the other one to be exactly the same. Similar, we're thinking stretching, shrinking. That's going to mean things like that the angles are congruent, the angles are the same, the sides are proportional. Those are the ideas in this problem. So thanks very much. Remember, suggestions, anything to make these things more helpful, that's what I'm interested in doing. So thanks very much.